Hey, I wanted to jump on here and just try to help out with this problem in 6.4. I'm not sure how well it translated in lecture, so I wanted to try to explain where some of this content is coming from and how it's related to what we had talked about before. So in my version of this question, I have y equals 1 minus natural log of 4 minus x. So there's a few things happening at the same time with this function. If I rewrite it, I'll have negative ln of negative x plus 4 plus 1. I want to rewrite it just so it kind of resembles what we've talked about in class. Here we have a negative sign in the front, which that's going to cause a reflection. We have a negative sign here with the x, that's also going to cause a reflection. We have a plus 4 here, which is a horizontal transformation. And normally, this would shift 4 units to the left because it is plus 4, and with horizontal, it's the opposite. However, because of this negative sign here, it's actually going to shift it to the right 4 units because we have that horizontal reflection going on. So that's what's going to cause that to happen. We have the plus 1. It's probably the easiest thing to notice. That's just going to shift the graph up by 1 unit. So because of the negative sign here, and because of the plus 4, well, if there wasn't a negative sign, it would have shifted it to the left, but because of this negative sign, it shifts it to the right, and that's kind of confusing. This is going to change the domain of the normal function. So normally, the domain of a logarithm function is from 0 to infinity. But because of this shift and reflection, it changes the domain. So now the domain of the function is negative infinity to positive 4 non-inclusive. So any number that's less than 4 is what we want to write. And we'll write that as an inequality x is less than 4, and that will do it. So that's a little confusing because we have a reflection and we have a horizontal shift. And so that changes the sign, and so it shifts it to the right because of the reflection. That's confusing. So I hope that helps with what's going on with the domain. The next part is to determine the horizontal asymptotes. Okay, well, normally the horizontal asymptote of a logarithm function doesn't exist. And that is still the case for this. Even with the shifts and even with the reflection, that's still true. So there is not a horizontal asymptote, even though we have a vertical shift, vertical reflection, horizontal reflection. We still don't have a horizontal asymptote. The vertical asymptote, which is normally x equals 0. It's normally x equals 0. Because of the reflection inside, and because of the negative here for the x, and the plus 4, that's a horizontal reflection and a horizontal shift. So because of the combination of those two, it shifts the graph to the right. And so this is going to shift it. It's going to shift this to be x equals 4. So it shifted that. And so now the horizontal asymptote is at 4. Okay. Hopefully that helps. Okay. And then how do we find the x and y intercepts? So I'll explain this. This is the part that I'm really concerned did not translate within class. So for an x-intercept, that implies that y equals 0. If y equals 0, then I can rewrite the equation 1 minus ln of 4 minus x equals 0. Okay, if that's true, then I can use a little algebra. 1 equals ln 4 minus x. Okay. Now, how am I going to solve for x when it's inside the expression, it's inside the argument? And this is a technique we haven't quite talked about yet, but you can raise the function, or you can raise the equation into the exponential. So because this is a natural logarithm, I'm going to write e to the 1 and then e to the natural logarithm. And what will happen is I'll just get the number e and then 4 minus x. Because they are inverses of each other, they'll undo each other, and I'm able to do that. Now I can solve for x. If I move this to the left, it becomes positive, and I can go 4 minus e. That kind of looks like I wrote negative 4 minus e. Okay, so that would be the x-intercept, and so the point would be 4 minus e comma 0. Okay, so that's what the x-intercept is. What would the y-intercept be? Y-intercept implies that x equals 0. If x equals 0, I can plug that into the function y equals 1 minus the natural log of 4, since x went to 0. So this would be the y-intercept. Well, I can't just plug in then, I have to plug in the point. So this is 1 minus natural log of 4, and then close parentheses. So notice I have parentheses around the 4 and then a parenthesis for the ordered pair. Okay, that's all I wanted to mention. Picking the graph should not be too hard. You can always use Desmos to see how that works, but I wanted to jump on here and at least explain how you could find those x and y intercepts and what's going on with all of these transformations. So I hope that helps. I hope that helps with your homework, and please don't hesitate to message me if you have any further questions, okay? All right, thank you.